Hey guys, it's Brian here again, and this is going to be part 3 of working on our Twitch game. We've got a new VS Code theme, new window layout. Hopefully things work out better. So if you remember from part 2, basically where we left off is we have the player moving across the screen on the bottom here, and it's colliding with the enemy. So as the player moves across, we want it to collide with enemies, try to fight it, keep on going, maybe there'll be more enemies, and then finally just get to the end of the level. This is a passive game that will be interacted with by Twitch viewers, and basically we want to make a dungeon crawling experience, basically. Now, the issue that we were having before is I was having trouble with the collision between the player and the enemies. I could collide the player with an individual enemy, but if I tried to actually make a collision happen between a enemy group, which is a thing in Phaser, as opposed to a single enemy entity, it wasn't colliding with the enemy as a static object, meaning that I want the enemy to be static and not actually respond to any input. So when the player hits it, it just should stop, should try to fight it, and then move on to the next one once that's done. I did a little bit of research offline and actually figured out what the issue was. Basically, what I was doing before was actually creating an enemy group just of the regular arcade group. There's actually a static group to do exactly what I wanted to do. So when we had created the enemy within a group and even set that individual enemy that it was created to have a static body, it was still being pushed by the player when it ran into it. But now that we have it as a static group, and then when we load in our map, we set up our group, we have the enemies be a static group as opposed to a regular one. And then when we load through our objects within the tiled map and we create our enemy, it actually is created in this static group now. And so like you could see again, the player, when it runs into the static group enemy, it'll actually stop. So this will be helpful because we can manage the enemies as a group instead of having to individually declare entities for each individual enemy in the level. So we should be able to handle things a lot better that way. Okay, now moving on to today. What I want to work on today is basically the combat. I want to be able to have the player fight the enemy, have some sort of delay between attacks. So you would have an initial hit with the enemy, and the enemy would damage the player damage the enemy, some sort of timeout, and then the process repeats itself, and standard combat rules apply. You deal damage until your HP reaches 0, and whoever is standing wins. So basically the player will keep on going through, try to fight as many enemies as they can in the level, or get to the end of the level and actually win. So what we're going to do is work on that. So what I'm going to start with is, and remember, this is all a learning experience for me as well as you guys, so I'm going to start by doing a little bit of exploration about what is kind of available to us. So what happens when the enemy, or when the player collides with the enemy group? We have that set up here in our set collision function, and basically that's just saying to add a physics collider between the player and the enemy's group. And here's a callback to run when the player hit the enemy. And you can see that that actually gets called properly because we see the console log message up here, player hit enemy. Great. Now, what you can actually, I believe, do is have a reference to the objects that were actually the ones colliding. So if we go here, rerun this, I want to see what the references are that we get in the callback. Okay, arcade sprite, active. So we have a reference to the arcade sprite itself. Now, the one thing that I want to make sure of is that we can destroy that individual reference to the enemy. So remember, we're colliding with a group of enemies, but I only want to destroy the single enemy. So let's see if we can figure out how to make that happen. And actually, to make sure that works properly, let's go ahead and drop another enemy into our level. So that's going to be an enemy, that's an enemy, okay. And so we're in tiled where we made our actual map. Let's see here, default, we want to export it as JSON, default JSON. Okay, replace that please, sure. If we reload, now we have our two enemies inside the game. Okay, great. So what I want to see is with object2 likely, do we have a destroy function? We do have a destroy method if you want to be pedantic about it. So destroy the game object. Okay, that should actually work fine, I believe. I believe we should just be able to destroy it. Okay, cool. Interesting that the player... Oh, I guess the player loses the velocity because it collides with a static object. So we should be able to say set velocity x and just reset the velocity of the player. Once it destroys the enemy, it'll just keep going. Boom. Boom. Perfect. Great. Okay. Good then. So that works out pretty well. So what we have here is we have a reference to both our player and the individual enemy. Let's see here. Because what we're going to need to know is the type of enemy and the HP that the enemy has. Because when we fight with the enemy, we want to actually deal damage to that individual enemy, and say we might have multiple types of enemies. We need to know what we're colliding with specifically. So, I wonder if there's anything in here. Key enemy. So there's that. Can you give a name to the sprite when you create it? So what in this function, what other things do we have access to? Frame key. Okay. This should probably return. That returns an any. Okay. That's new enemy, and I wonder enemy dot. Because this should be an arcade sprite, right? Oh. What I want to see is if we can tag the enemy with some sort of data. Arcade sprite. So let's see here. Phaser 3. We do some Googling over here. Here's the add data to group sprite. Config. Group scene add group config sprites. Add custom properties, but this is from a while ago. Now, I wonder if you can just say that new enemy dot type equals test type. Now, I wonder if that will actually register here. No, it does not. Oh, yes, it does. I'm sorry. Type, test type. Okay, great. So we can set custom data on the enemies that we create. So just to walk it back for a second, what's happening here is basically the create function of the group of enemies is basically returning the new sprite that was created and added to the group. From there, we have the reference to that individual sprite, so we can just set some custom data on it. So what we're going to do then is actually say name enemy, and then we're going to add some custom properties. Enemy type. We're going to say, I don't even know what that guy specifically is. What are we loading it from? A goblin, I guess? All right. So we'll call him goblin then. All right. Save that. Add this one to you as well. Enemy type. Goblin. Now, I will show you the reason why I'm doing this in just a second. Export as default JSON. Okay, cool. Now, what we're going to do is that when we create this enemy, let's just log out the data we actually, the data that we actually get from our creation. That would just actually autocomplete properly. Yeah, so, all right, creating object and creating enemy. Okay. Properties. Boom. Okay, great. Here's what we're looking for. So when the tiled map data gets parsed into Phaser, we have access to these custom properties, right? And remember, that's how we actually know that the object is either the player or the enemy. If we basically go back into here when we're creating the enemy, and we have this object that was given to us by the tiled map parser, we have the properties in it. So we can see the property has been added to the enemy that we're creating. So we have this enemy type now that we can reference. Awesome. So let's think about how we want to do this, not in a perfect way, but a smart enough way where it can scale to multiple enemy types. So let's think about this here. What we can have is, let's go ahead and we'll have some, well, we don't want a file, we want a folder. Let's have some data. Monsters. All right, so, give it a default export, and we'll say goblin. There we go. That's it. Data. Is that gonna make it better? All right. Let's just do it this way. I always mess up with the syntax of what you're supposed to do for this. That works at least. So we're just declaring a constant and labeling it as the default export for the module. So what we're gonna do here is things like keeping track of the common variables that we want between monsters. So say we want to have like an orc as well, then we can name orc and HP might be 20, sure. But this will allow us to be dynamic in how we fight the monsters and actually probably how we create them as well. So what we can do actually, all right, so let's go ahead and this will be goblin instead of the enemy. So that's gonna make an issue because it doesn't know what key to load the images from. Create enemy, here we go. We wanna change this key for the asset that we loaded to be goblin as opposed to enemy. Okay, so the reason I did that is because what I wanna be able to do is that when we have our enemy, I wanna pull in data dynamically from another source to kind of keep things separate and keep things organized. So inside of our monster data, what we can also have is sprite key, goblin, cool. So what I'm gonna do over here is the first thing I need to do before we even load in this data, I need to find out what the enemy type is when we're creating it, right? So we're creating it, but we need to find the enemy type. Do we have a utilities class yet? No, util, okay, tiled helpers. Get object name. Oh, okay. Export. So this can go in the tiled helpers because it's related to the information that we're pulling in from tiled. So what we want to do here is get the enemy type. Get enemy type. We're passed in an object. We want to return the string of the enemy name. And basically very similar to what we're doing for the getting the object name is object.properties that find the property that is prop.name is enemy type and return the value of that property. So what we want to do here then is we'll import that first. Get enemy type. It's cool. And then back in when we're creating the enemy type equals get enemy type of the enemy, right? So what will happen here, enemy type is enemy type, all right? So what should happen here, boom. All right, when we created the enemy, we got the enemy type, goblin. That's great. Enemy type here, again, because we created two goblins, but we're able to properly get the enemy type. Now what we can do is actually reference the data of that. So we want to import the monster data from monster data, right? Nope, it's just monsters, right? I just realized that is, let's just keep everything as TypeScript. That's fine. Data monsters, yep, okay, that's referencing the right path. Now what we can do is we can say the monster data is, well, I don't want to name it the same thing. Monster info is monster data enemy type. So this will look inside the monster info to find, or this will look inside the monster data to find the info for the proper enemy type. So remember, the monster data is just an object that we're outputting here. So we can reference the key name of the monster type. So the important thing is that this key name, goblin or orc, is corresponding to the tiled enemy type that we set up here. So that way we can kind of hook all the pieces up together and figure out what enemy we're trying to get the information for. So what we should be getting here then is monster info. And if we look here, we can see we have the monster information now. So we've got the HP, the name, the sprite key, which is what I'm going to change over here. So we're going to say monster info.sprite key. And what I suppose we can probably do is actually, get enemy type is a string. I'm trying to think if we wanted to find an interface of this to kind of make our autocomplete a little bit nicer. So if you notice when I typed monster info dot, we didn't get sprite key as an autocomplete option. Well, what I believe we should be able to do is just say, let's see here. Data will be an array of type. We'll declare an TypeScript interface here of iMonster data. And this will, I believe, actually you don't use an equal sign there. So we have a name, which will be a string, HP, number, and sprite key, which is a string. Cool. This will be an array of iMonster data. Okay. So what's this complaining about? Oh, that's silly. Of course, no, it's not. So these are not. It's not an array of that at all. What it is? Let's think about how we want to define this then. Because do we want it as an object, or we can have it as an array that we parse through? What's up, Lancemaker? How's it going? Let's see here. I might just, let's see here. So we can define this object. Something. Yeah, it's basically somewhat going to be a roguelike. So if you want to check it out, I have videos for the first two parts of this. But basically the idea is to make it essentially a roguelike, but for Twitch stream interaction. So other game dev streamers have had these types of games. I don't know if they've made them or used them from somewhere else, but I kind of got inspired from seeing that. And basically all it's going to be at its very simplest is a viewer will be selected at random from the stream. They'll have their character move across the screen as a dungeon crawler, fighting enemies as they go across, trying to get to the next level. And then, of course, you have all the other elements of these type of things where you can get loot, and there might be other interaction with the streamer itself and all that kind of thing. Oh, you've used Phaser 3? Or have you used Phaser 3 or 2? Is Phaser 3's relatively new from the earlier this year. They just came out. It's a pretty big rework. I've used it a little bit before. And liked it so far. Alright, so what we want to do here is let's actually... It won't be too expensive because we don't have a lot of characters, so or a lot of enemies. So we're just going to make this an array then. So we'll delete that, make this, that, delete that. So enemy type is going to be goblin. Okay. We'll add this here. Enemy type goblin. Oop. String. I used it once and I was amazed with what I could do with that. No, nothing about the frame. Yeah, it's super easy to pick up. I mean, the biggest thing I think that people talk about is the prototyping of it, which is pretty great. It really does work pretty darn good for prototyping, so definitely happy about that. And I prefer to work in JavaScript and TypeScript, and I'm just trying to learn more about them, so I prefer using that too. Oh yeah, usually use Unity. Yeah, that's I guess the other one I've used the most. They both have pros and cons. I like them both a lot. They're obviously both really easy to use. Unity's great because obviously it supports a lot more platforms natively. I mean, Phaser out of the box just is for web games typically. I actually had run it as an Electron app before to make a desktop game with Phaser. But yeah, not usually used for things like that. But yeah. All right, so enemy type is going to be that, and enemy type work. All right, so back in here, when we get the enemy data, we're not going to be able to get it like this. What we're going to actually export here is monster data is going to be data, and then get monster data. So let's just export actually, we'll do it this way. So we'll export that, export const get monster data, monster type. And what we want to return is the monster data interface, right? And all we're going to do here is look through our data to see what actually, I don't even know if we need to export this because we're just going to be calling get monster data. So what we can do is just return data.find monster, and then we're looking for the monster whose enemy types equals enemy. We should rename this to enemy type, right? Monster data. So what are you complaining about exactly? Monster. So I think it might be wanting us to just declare. It's the one thing about TypeScript, and I'm trying to learn a little bit more about it. Type blah 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 or blah 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 is not assignable to type iMonster data. Property string is optional in type. Oh, okay, so what's it saying here? Oh, it's optional. I see, because we don't actually have a sprite key for the orc, so I'm guessing, yep, boom, okay. So that's one nice thing about TypeScript right there, is forcing me to conform to my iMonster data interface. So basically it was throwing an error because my orc that I defined here did not have a sprite key, and I didn't define this as optional. So what I suspect is if I say, hey, this is an optional thing, then we get a different error, but okay, anyway. Don't need to go too much into that, but that seems to compile fine. And let's see here. Okay, so this is going to return the actual monster data. So if we go back into here, it's complaining about compiling still. What's going on? No, it is able to. Can I property goblin? Okay, that's fine. So monster info, enemy type, get enemy type. Okay, yeah, here's what we want to change. So we want to, instead of doing this, instead of getting the monster data from here, we want to import get monster data function. And in here, get monster data function for the enemy type. We're being a bit verbose here with the 2 lines, but that's okay. And as you can see, it actually worked fine now. So now we're properly loading in the monster data from our monster data cache, or whatever you want to call it, and we get the info properly. So we have the enemy type, the HP, name, okay, all that stuff, great. So what we want to see is we've got this new enemy, and we want to actually change some of this stuff. So what we want to do, and also, so the whole interface thing, what we should be able to do is say dot, see, now we have autocomplete here. So because we defined it as an interface in the monsters.ts file, we're saying that, okay, all of these things represent this structure. When we come back in here and we have an instance of one of those things, the monster info, we get some nice autocomplete stuff. So we can just type in Sprite. Just a nice little thing that is afforded to us from TypeScript. So we want to set a couple things for the new enemy. So we want to say it's HP and probably maybe a name, monster name. Name. So what will happen is when we collide here, if we look inside of object 2, HP, we have 10. Monster name, we have goblins. So we can reference that information for when the fight actually happens with the player. Great. So what we want to do here is actually handle the state of being in combat. Now, what I'm thinking about this is a very simple finite state machine. Is that what they're called? So basically, in our update function, it's going to basically update things based on a certain state. And what we can say here then, state equals moving. Nope, this dot state. Let me say private state is a string. Okay. So what we're going to say here is that we want to update based on the state. And what we'll say here is if this dot state equals, let's see here. Can we define enums here? How are TypeScript enums defined? Let's see what that actually looks like. Okay. All right, that's fine. So we can just define an enum of state, where we can say moving, or if we're in a combat state. So the two states we're going to have right now are either between moving or being in combat. And based on that state, we want to update things differently. So maybe we want to actually have switch on this dot state and case state dot moving. We don't actually care about that at the moment though. State dot combat is what we're going to be more interested in. What's this complaining about? It's not even interesting. Okay, so this is actually enum. So this is not going to be state. Yeah. So this is going to be f type state, and this is, we're going to say state dot move. Yeah, moving as the default. And now that should load up just fine. Okay, that's good. Console.log. And this is going to print out. We are in combat. It's going to print out a lot if this works how I think it should. In this collider, we should say this dot state equals state dot combat. Oh. Capital combat. All right, great. So what's going to happen is we're going to change state once we hit that guy. Boom, we're in combat. Great. We've got a ton of messages going through. Now, what we want to do is have attacks happen between the enemy and the player at a certain interval. So let's define that interval. Const. And we're going to probably break this out into multiple files and classes a bit later, but I'm kind of just trying to keep everything moving for now, so we'll worry about that a little bit later. So for now, we're going to say attack cooldown. I don't know what that's actually going to work out to, so we'll just say 2000 for now. That might be way too long, but let's just assume that's okay. So what we're going to want to do is basically rely on the update time of each frame, which is a time, a delta time that's provided by Phaser. And we, update time. Oh, so actually, I'm looking at this scene. Update. Oh no, this is delta. So actually, what if we look at a scene for phaser, and in the update, yeah, okay, cool. So that's actually what we want. We want to know the delta time from the last update call. So we will have the current time. Okay, that's fine. Data if you can set time. Okay, let's just move the cap. Yep. All right. So basically, based on different frame rates of different computers, the delta time gives us a way to smooth out timing things across different frame rates. So whether you're running at 60 or 120 frames per second or anything in between or below or whatever, the delta time will, as long as we base everything off our delta time, it'll operate in the same manner based on those across the different frame rates. So this is for things like, a lot of the time, animations rely on delta time. So if you're running a new animation frame per frame that's rendered, if you're running at a higher FPS, the animation is going to run faster. So the delta time is usually used for things like that. Things like velocity or positioning movement. If you want to adjust something by a certain position every frame, you can use the delta time to have it be normalized across different frame rates and all that kind of stuff. So what we're going to use it here is that we want to know if the attack can happen between the player and the enemy. That's going to be based off of this attack cooldown variable here. What we're also going to have is private attack on cooldown, which is going to be a Boolean. And when we initialize everything here, we want this attack on cooldown. So this will be our flag to say, hey, it's attacks on cooldown or not. We're going to want to have private attack cooldown timer, right? This is going to be a number. So this is going to be the timer to count down until another attack can actually occur. And what we can do in here is handle attack state. Let's break this out into another function. Handle attack state. Cool. Now, what we're going to want to do is attack here. We're not going to alter HB values or anything like that. First thing first, we're just going to handle when we can attack or not, or delta time. We're going to need this delta time of the function here, so we're just going to pass it right there. What's it complaining about here? Oh, sure. Delta time, that's fine. Now, if attack on cooldown, if not, console log player and enemies attack each other, right? So if it's not on cooldown, then we want to say this is going to be, yeah, going like crazy. And then what we want to say here, though, is set the attack on cooldown after an attack happens. So the attack's on cooldown. Great. We also want to set up our timer, right? The cooldown timer should be equal to the attack cooldown. So we want to start this initial timer here. Just to check and see, I want to see what the delta time looks like here. And when it collides, delta time is 16. Okay, that seems fine. 2000 might be a reasonable number then. So what's going to happen here is we need to handle the case if the attack is on cooldown. Okay, so the attack's on cooldown. We want to reduce our timer, cooldown timer, by the delta time. So remember, the delta time is the time since the last rendering of a frame. So we reduce our cooldown timer by that amount, and then what we're going to say is if this dot attack cooldown timer is less than or equal to 0, then the cooldown, or the attack's no longer on cooldown. So attack on cooldown equals false. And what'll happen is the next time this will actually go ahead and render again. So you can see right over here, actually, it is working properly. So every X, probably 1, 2, yeah, it does work out to about 2 seconds. Every 2 seconds, the player and enemies are going to attack each other. And this, you can see, this number just represents how many times this message is being printed out. So right now we have a functional loop that will handle our combat state. Attack, the attack goes on cooldown. Once the cooldown's up, the player attacks again. Great. Now what we need to do is handle the actual attack. Do I declare that the player has an HP value anywhere? Let's see here. Create player. What do I do? Okay. So we're gonna wanna add player HP equals 50. I don't know. That's fine. Oh, so we're gonna have to actually, let's see how we want to do this. Now is probably a good time to actually break this out into a new class. So let's see. Custom sprite class. Class sprite. That's not what I want. Here we go. Yeah, that's okay. So what we're gonna want to do then is, let's go ahead and we've got our scenes or utility. I want a new folder. Call this maybe sprites. I think that's fine for now. We're gonna have a player. We're gonna have this as the export defaults class of player extends phaser.gameObjects.sprite, right? And actually, that might want to be an arcades physics.add. Yes, this is going to return physics arcade sprite. Okay, so let's just actually do that. Physics arcade sprite. Okay. So constructor will be call the super. So the constructor will be called with the X, the Y position, and the sprite key, right? This is a number, that's a number, that is a string. We're going to call it super Y sprite key, okay. What's this? We have 4 or 5 arguments, we got 3. What is the other argument? What? Actually, is that what we want? Sprite. Let's actually do a little bit more Googling. 3 custom arcade sprite class. So I want to look how to create a custom sprite class. Object, what's this? ES6. Okay, so he actually has a sample, it looks like. Maybe. Oh, yeah, here we go. Okay. Phaser game object image, so constructor. That's fine. Okay. Yeah, it's .children.add. That seems fine. Let's see here, actually. 3. Let's go to the examples for them. I wonder if we actually have. Sprite, game objects, blah, blah, blah. I want to look for an example of a custom sprite. I think I'm basically there, but let's see here. Super is expecting. Oh, the scene. The scene is what it's expecting. Interesting. Okay, so scene is phaser. So what this should be is phaser.scene, I would guess. And we'll say scene here. Okay, that seems to be fine. I'm gonna have to pass in the scene here. So we'll come to that in a minute, but what we're gonna do here is we will say this dot HP equals 50. Sure, whatever. So is this on type player? Oh, duh, because we need to have private HP, right? Is a number. Is that the syntax? Seems right. Okay, cool. So let's not make that private. Let's make it public for now, so we can just alter it. We might want to change that later. That should be fine for now. So what we're going to do here then is we want to import the player from Sprites player, right? And inside of the game object, we want physics.add sprite. Let's see here. Create sprite. I think what we should just be able to do is say new player, give it a scene, which is this, player.x, player.y, and player for the string there. I had a feeling this would be an issue. And I refer, what? Got one. What's that now? Expected 3, 4 arguments, but got 1. How's that? Well, that doesn't make much sense to me. Yeah, this should refer to the scene, right? I think that makes sense. So what maybe we can do instead, actually, is can we just pass it the group? Physics not that. Oh, this is kind of silly. Oh, okay. There's a better way to do this, I think. So for the player here, this dot player, this is going to be of type player, right? Then what we're going to do in here, we can just copy this over to the player. Let's just add this to the game world within the player class itself. Doesn't work, of course, because it doesn't physics. So scene.physics, right? Got 1. Yeah, okay, so we don't want this. We want the X, Y, and the sprite key. Yeah. Okay, so in the constructor, it's going to add the player to the game world, I believe. And then inside of here, all we're going to do is say this dot player is equal to new player, with the scene being this, player being player X, player Y, and then player for the sprite key. Now, that seemed to work properly, but the problem is that it doesn't have a set velocity X, which is interesting because, we say it extends the sprite. I'm sure I'm missing something here. Let's see here. Let's see what other things we can come up with here. Was that a game? There's actually a Phaser 3 tutorial. Let's see how they do it in here. So the player is just, yeah, no, they just use physics.add sprite. Okay. I want to see Phaser 3 example games. Let's check out some examples of some actual games. Excuse me. All right, so create the project, blah, blah, blah. I want to see if they create it with a custom class. No, they're just adding the player in the same way. These are 3 custom, yeah, sprite class. I'm sure I'm missing something very, extending sprites demo. Oh, that sounds. This is from Phaser 2. Yeah, that's using old non-class stuff. Darn. Okay. That looks promising. This is from when though? Oh, Phaser 3. Oh, it's Phaser 3. Okay, so this should actually work. Tutorial. You should put an email. All right, let's just look through here and see. Phaser.class extends Phaser.scene. Battle scene, boot scene, sure. Now, that's fine. Blah blah blah. Unit. Okay, here we go. Initialize function. It's an interesting way to declare things. So, I wonder if that actually needs to be the case like that. Initialize. I can define it like this, I guess. I mean, let's try it out and see if this actually works out a bit better then. So actually, I'm just going to resize this window if I can. All right, there we go. That's better. All right, so we'll go through here, and what we're going to do then is I'm just going to take this to the other monitor so I can see it. But what we're going to say is for this player, so const player equals new phaser dot class, which doesn't even seems like TypeScript likes that. No, that's not. All right, let's see here. Phaser 3 TypeScript extend sprite. This is another one. I extended sprite to the scene. Yeah, okay. Okay, this looks exactly like, yep. Okay. That seems pretty good. All right, so this is the same exact issue as what I have. Okay. Player does not add existing. Oh. Okay, that's actually not what I thought at all. How do I extend the game object? Okay. Add existing new extended object. Oh, okay. So there's actually a different API call I need to make. So what I should be doing here is definitely not this. But what it should be then is if I have a new extended object, so we can say this.player, sure. I want to keep it all in. Let's see here. What might we be able to do? Add existing for physics anyway. Use a physics point. This dot, yeah, okay. So this dot physics dot add existing this dot player. That should add it to the world. Now, okay, we're getting close. Does not have the proper key for it. Player is the proper key. The physics body is there. That's good. We can set the velocity. This all makes sense so far. Okay, let's take a look at our player class now, because what are we doing here wrong? This should be the scene, X, Y, and sprite key. player. Let's just log this and see what we're coming up with. Player is the player. Yes, right. Active true, sure. Type sprite. It's fine. HP comes through, which is great. So that's on our player class. That's good. That was added here. What I want to know, why is it not rendering the proper image? Texture. Yeah, key player. Well, what in the world? I wonder if it has anything to do with... No, doesn't make any sense. I was trying to think if it might have anything to do with rendering below or on top of our world itself. Like, just to double check about that, let's go ahead and just not create the map itself. We're gonna get an issue? Yeah, I guess we get an issue. Oh, because we're not creating the objects. Oh, that was exactly the opposite of what I wanted to do. And then let's not create this, but create the game objects. That's what I wanted. Okay, so it's just not working properly. Nothing to do with the other tiles on the map. It just doesn't render the player itself. So if we create, when we're creating the player, we have a new player. We pass it in the key. We know that we are the key, just to double check that we're passing in, gets passed in properly. Should say key player. Yeah, it says key player, so we know that the right sprite key is being used. But what in the world is going on with this? The issue, I presume, is that it's not getting loaded from our assets properly, but I'm not totally sure. But I think that's a good time to break it. I'm going to probably do some research on this off stream, try to figure things out a little bit. And basically, we did a little bit more today than I thought. So we figured out how to extend sprites. We created our separate player class. We figured out how to actually have state occurring between our combat state, and we figured out how to actually have attacks happen, go on cooldown, come off cooldown, and actually execute the attacks that way. And you can see it's still going right now. Yeah, so next time, let's actually work on actually fighting the enemy in terms of bringing down their HP and then bringing down our HP, destroying enemies, moving forward, getting loot, and hopefully winning the game. So yeah, I think that's about it for this one, and I'll see you guys next time.